So chapter 4, we will begin with probability. Today we will do 4.1 and 4.2, which is the introduction to probability. And many of you, or all of you already know that probability, just in short, what are the chances of something happen, right? That's what probability in short is, right? We try to find the chances, the percent of something occur. So in the definition is basically they tell you that the proportion of the event, which is what we're looking for, over the total outcome that we have, or the over item we will encounter later. So the first thing that this is a new item we have is the law of large number. The law of large number will connect us to the central limit theorem later. But the law of large number basically tell you that if we were to do an experiment over and over and over and over in the long run, in a lot of time, it will come out to a true proportional or a true probability. Meaning is basically tell you that if you know that if I flip the coin, if I have a quarter in my hand and I flip the quarter, the probability of the quarter land on a tail will be 1 out of 2 sides, right? 1, which is I have 1 tail out of 2 sides, which is 1 head and 1 tail. So 1 out of 2, which is 50%. But what that say is does not guarantee that if I flip 10 times, I will have 5 head and 5 tail, right? I may have 7 head, 3 tail. If I flip 100 times, I may have 60 head, 40 tail. If I flip 1,000 times, I may have 550 head, 450 tail. And if I flip 1,000,000 times, and then maybe at that time, I will have 500,000 head and 500,000 tail. Meaning basically they tell you that if we collect a lot of data, or in our case, if we do a lot of the same item over and over, they will come out to that theoretical probability, which is 1/2, which is 50%, okay? So the other thing we have, or the definition we have, is a sample space, which is in short, the sample space is the total possible outcome that we will have in our experiment, which is if I flip a quarter, the sample space will be 2 because 1 head, 1 tail. If I roll a dice, the sample space will be 6 because the standard dice have 6-sided, which is contain 1 dot, 2 dot, 3 dot, all the way up to 6 dot, right? If I talk about a deck of cards, the standard or the sample space will be 52 cards, right? And the event is basically, in short, what are we looking for? What is the criteria? What is the description? What is the category that we're looking for? So you will hear me say a lot that what we're looking for over the total. And that's what probability is. What are we looking for? What do we have over the total possible outcome, the total item we have? And as you will see, a lot of this thing here, P, open parenthesis, A, close parenthesis, this is your notation for probability, which is the A stand for any event. The event can be a tail. The event can be rolling dice and land on number 6. The event can be anything, which is the A will be changed to something else. But when you see P, open parenthesis, that is what basically tell you find the probability of this item. And in short, or in terms of the formula, this is what they tell you is the probability of event A. The event A will have some K outcome, meaning what we have that relate to A. In terms of the tail, the K will be 1, right? Over the number of outcome in the sample space, which is the total item we have in all, which is the N. And as I told you in statistics, the N, the lowercase n, you will see that it's always the total of the item, right? So in our case, if I flip the quarter, the N will be 2 because I have 2 sides, right? The head side and the tail side, right? So again, number of outcome, which is 1 out of 2. And a few facts about probability, or the property of probability is your probability. The good thing is when you find the probability of whatever event you're looking for, it will always be between 0 and 1. The smallest number you can get will be 0 because the probability of the event equal to 0, meaning that event is impossible to come out. There's no way you can find that probability if its probability is equal to 0, meaning it's impossible for that description, whatever you're looking for, to come out. And if the probability is equal to 1, meaning that event will always come out. Whatever you do, that's the only event that will come out. Okay. So again, if it's equal to 1, it will certainly always come out a curve. If it's equal to 0, it's impossible to occur. And the good thing, like I mentioned earlier, is whenever you find a probability, your answer will always be between 0 and 1, meaning it will be a proportion. Your denominator will always be bigger than the numerator, or it will be your decimal. So your answer will never be 1.25 or 1.78. Okay, your answer will be 0.09, 0.099, 0.078, 0.002, something in that nature. And if you find a probability and it's 3.72, you did something wrong. Okay, so that's one good thing about probability is whenever you try to find it, it will always be in decimal. So let's take a look at this example. So assume that this dice is fair. Like I have a fair dice and I roll this dice. The sample space, as you can see, the sample space, which is the total possible side that can come out, is 1, 2, 3, 4, 5, 6, which is each side contain 1 dot, 2 dot, so on up to 6. And again, this dice is fair, meaning they are not weighted, meaning every side have a same equal chance of coming out. And they ask you to find this probability. They ask you to find the probability. If I roll this dice, find the probability of this dice land on number 2. So looking at this thing here, how many sides contain number 2 do I have? Which is I have 1 over the total, which is in this case, the total is 6. I have 1 side contain 2 dot over 6 total possible sides. So the probability of 1/6, which is if you want to convert to decimal, you can take 1 divided by 6. And similarly, if I roll this dice and they ask me, what is the probability, find the probability of roll this dice and this dice land on an even number. So again, the even number, how many even number do I have? Well, what is my description? Do you agree that this all my even number, the 2, the 4, and the 6, which is in this case, I have 3 sides contain the even number out of the total, which is in this case, I have 6 total. So 3 over 6, which is reduced to 1/2, or in short, 50%, 0.5, okay? So similarly, they ask you, if I roll this dice, find the probability of this dice land on a number less than 3. So what are my description? My description is the number less than 3. We know that number 2 is less than 3. Number 1 is less than 3, which is, again, reminder, 3 is not less than 3. So 3 does not fit that description. What is my event? My event is the number less than 3. How many items is in that event, which is I have 2. Over the total, which is 2 over 6, I can reduce to 1/3. And if you want to convert to decimal, would be 0.333333, right? So in the sense, this is in short, this is all there is in probability. And you will hear me say a lot, whenever you find a probability, the most important thing that we need is we need the total. And the second thing is we need to know what we're looking for from the total. In that total, how many fit the description that we're looking for. Similarly, in this case, we know that the total, we still have 6-sided. And now, what are the number that is greater than 1? So we know that 2 is greater than 1. 3 is greater than 1, 4 is greater than 1, 5 is greater than 1, and 6 is greater than 1. So in this case, how many number is greater than 1? We have 5. Out of what is the total? We have 6. So looking at this thing here, first of all, question in how to find the probability of something and how the probability notation look like and what we're looking for in the probability item. And again, you all know the chances of something happen, the chances of something occur, which is that is the probability. And E and F, I just want to give you this thing just to show you that there is a chance that you can find the probability of 0, which is if I roll this dice and I ask you, find me the probability of this dice land on number 9. We can see that again, we have only 6-sided and the maximum number is 6, which is the 6 dot. There is no side contain a 9 dot, right? So there's no side contain 9 dot, which is 0 out of the 6 side, which is 0 over 6, which is eventually is become 0, meaning it's impossible for you to roll this dice and this dice land on a face that contain 9 dot. Okay, reminder, this 9 is not the total side we have. This 9 is the specific event that we're looking for. The event that we're looking for is the side that contains 9 dot. The 6 dot is the biggest, which is, that's why it's 0. And similarly, find the probability that if I roll this dice and this light land on a number less than 7, do you agree that all of this number 1 all the way to 6 is the number of less than 7, which is how many sides of the number contain less than 7, which is we have 6, and 6 over 6 we will give equal to 1 whole number, which is in this case the probability of me roll this dice and the dice land on the number less than 7 is equal to 1 or 100%, meaning I will always have a number that is less than 7. I am guaranteed. Okay. So looking at this item here, question on how to find a probability. Question in terms of this. Well, let's take a look at another example, and let's take a look at if we have some compound event. So everything I mentioned earlier is a simple event, meaning we have only one item. We find the number 3, we find a number bigger than 7, we all find one event. And if we have multiple events, you will see in 4.2, the first compound event is the OR. And when we get to 4.3, the second compound event will be the AND. So the OR is basically tell me find the probability of A or B. Meaning basically tell me find the probability of A occur or B occur, or if both of them, A and B, can occur, that's fine. So the probability of A or B is basically add whatever fit the description. So for instance, let's say if I give you this information, this on Connect Math, they will give you some data and they will give you some story. So this story is basically the let's say that this is the result from my first test in one of my class. And I know in that class, I have freshman, sophomore, junior, and senior. And I have some A student, B student, C student, D student, and F student. So let's say if I have this data and this is the question they ask me. Find the probability. What is the probability if we go in here? If I go in here and I randomly select one student, select a student, and that student is a junior. So if I select one student and that student is junior, you can see that this is just a simple event. Why is simple? Because there's only one description. What is the description? The description I'm looking for is I'm looking for a junior. So in this case, how many people fit my junior description? I have 12. And out of how many people, which is in this case, do you agree that we have 12 people out of the total of 42? As always, in order to find a probability, we need to know the total, and from the total, how many fit the description we're looking for. The total in this case, we have 42 students, and 12 of them, 12 out of the 42 fit the description of junior, or I have 12 junior in this class. In that case, if I divide them, I will get 0.286. And ladies and gentlemen, if you remember in chapter 2, when we went over the relative frequency, the relative frequency is the same as probability, as I mentioned earlier when we went over that relative frequency. The only thing different last time is they say the frequency, which is the description we have, over the total frequency, which is in this case, we have the total item, right? And if they ask you for the percentage, If they ask you how many percent, what is the percent of the student is a junior, we will say, well, we move the decimal, which is 28.6%. I have 28.6% of my student or junior based on this information, okay? And similarly, I ask you this question here, what is the property if I select a random student and this student have a B, which is similarly, I have a simple event. My simple event is this student, a B student. How many B students do I have? I have 8. Out of what is the total student in my class? I have 42, which is 8 divided by 42. I will have 0.19 or 19%, okay? So let's take a look at this item. So the first item that is look a little bit different from A and B, you will say, oh, there's a word and. Is this a compound event? Well, it's kind of a compound event, but it's not this and then another one. As you will see, one thing is when we went over or when we will go over 4.3, there's another word and the word and we have will be a little bit different from this and we're looking for here. So this is what we have is we're looking for the probability, find the probability of a random selected student, meaning we only select one student. And this student is a freshman and also this student have a C on my test. So this and right here is not and then, meaning it's not that you do multiple times. This and right here is basically how many freshmen do I have that have a C student? Meaning this and is and also. I'm looking for a student who is a freshman and also that freshman have a C on my test, okay? So as you can see, there's only 5 freshmen who have a C on the test, right? So looking at this item is not the 9 freshmen and it's not the 10 C because I'm looking for a specific item that who is a freshman and also have a C. So in this case, there's only 5 specific freshmen who got a C, which is, you can see we have only 5 out of 42. And if we have 5 out of 42, 5 divided by 42 will give us 0.9119. Okay. So I will mention more about the other and when we get to 4.3, but right now just know that if we select one person and the word and come out, and if the word and come out, the and is basically we're looking for where does the 2 criteria intersect, where does the 2 criteria overlap, which is there's only 5 students fit both description. And if you look at D, you will see, well, this here comes the first, the word or, which is the definition of a compound statement or the property of A or B. So again, my A in this case is the freshman, my B in this case is the sophomore. So they ask you find the probability of a random selected student who is a freshman or a sophomore. So looking at this item, do you agree that all of these people, doesn't matter if they have an A, B, C, or D, all of these highlighted people is a freshman. And all of these highlighted people is a sophomore. Doesn't matter if they have A, B, C, I don't care. As long as they are freshmen or as long as they are sophomore, I want it. Meaning in this case, all we need to do is take the freshman plus the sophomore, which is I have 19 that fit the description that either a freshman or a sophomore over the total, which is 42. Which is if I divide this, 19 divided by 42 will give me 0.452. And basically, the compound is basically tell you that we have multiple description that we're looking for. And in this case, you will see whenever we deal with the word or, we will deal with addition. Okay. So similarly, if you look at this item, same data, and they ask you find the property of the student is a freshman or a C student. If you look at the highlighted item, or if you try to looking for the keyword you have is the word all. But looking at this item, do you see that this is my freshman people? And this is my C student people, which if you look at the highlighted item is different from the freshman and the sophomore highlighted item earlier. This one here, the freshman and the sophomore, they do not overlap. They have a freshman by itself, a sophomore by itself. I do not have any student who is a freshman and also a sophomore. But now when I go to this problem, I do have some freshmen who have an AC, right? Meaning I have some overlapping. So to be in short, one way we can do it, we can say, well, let me just count how many freshmen I have, and let me just circle how many C I have. And then I add them together, which is I have the 2, the 0, the 5, the 1, 1, and the 0, the 1, and the 4, which is I just take 2 plus 0 plus 5 plus 1 plus 1 plus 0 plus 1 plus 4. If I add them together, I will see that I have 14 individual students who is either a freshman or a C student. And if I divide them, I get 0.333333. So individually, I can just count each of them, add them up, and divide by the total. And as always, to find the probability, you need the total. Without a total, we cannot find the probability. Okay, so that brings us to our first definition, or our first formula, or the general rule for addition. The general rule for addition is whenever you see the probability of A or B, whenever you see the probability of A or B, which is your keyword is or. Let me change. Whenever we see this thing here, probability of A or B, all you need to find the probability of A plus the probability of B minus the probability that they have in common. So we have to minus them. So in that case, if we were to look at our problem here, if we were to look at A, and A, they asked me find the probability of a freshman or a C student. Meaning, again, my freshman is my A, my C student is my B. So what is the probability of a freshman? Well, do you agree that the freshman, I have 9. I have 9 freshmen out of 42. That is the probability of a freshman. If I go in here, I have 9 freshmen out of 42. Added to the probability of a C student, how many C students do I have? Well, I have 10 C students out of 42. Doesn't matter if they are a senior, junior, or sophomore, or freshman. I have 10 total C students minus how many freshmen who is also a C student, which is again the freshman who is also a C student. We did this earlier, which is we have 5 out of 42. And if you add them, you will see that we have 19. 9 plus 10, that's 19. 19 minus 5, you will get 4 out of 42. And 4 out of 42, which is the same as the above item. So yes, if we have, you will probably say, well, wait a minute, Mr. Ryan. If I have my data, if I have my raw data, I don't really need the formula. I just go in and take the 2 plus the 0, the 5, and so on. I have the answer. Yes, you do, right? If you have a raw data, you can do it. But most of the question, they don't give you the raw data. They give you the information, and then you have to decide it. You have to decide, is the information they give you have a, we call a mutually exclusive event or not mutually exclusive event. So what is the mutually exclusive event? So if the 2 events does not have anything in common, meaning it's impossible for the 2 criteria you're looking for to appear at the same time, then we say that it's a mutually exclusive event. Again, mutually exclusive event is when the item, when the 2 criteria we're looking for cannot occur at the same exact time, okay? And if they can occur at the same exact time, we just say that they are not mutually exclusive. So if we know that they are mutually exclusive, then all we need to do is find the property of the first one plus the property of the second one, and we call it a day. And if you remember last time, that's what we did, right? We find the property of a freshman. Last time, if you remember the previous problem, I asked you, I asked you last time is find the property of a freshman and find the property of a sophomore, which is, you can see the freshman and the sophomore, they cannot appear at the same time because I either have a freshman or I have a sophomore. I do not have a freshman and a sophomore together. So that's why they are not mutually exclusive. I can just add them up and I'm done. But if they have something in common, if they overlap, you have to check them out, okay? So let's practice. Let's take a look at this item, and then I will ask you guys if you have questions. So similarly, same information. Now they ask you this thing here. They ask you if we select one student, if one student is selected at random, find the property of that student is an A student or an F student. So when you do your homework, when you do your quizzes, when you do your test and the midterm, this is your keyword that you have to looking for. You have to ask yourself, do I have, can I, well, what am I looking for? And in this case, I'm looking for an A or an F student. So you ask yourself, well, this is my A student and this is my F student. Do you see that A student and F student, they are mutually exclusive? Because I do not have one particular student who make an A and also an F on one single test, because I either have an A or an F student on one particular test, right? If it's multiple tests, yes, you can argue if it's multiple tests, you can have an A and an F, but this thing here is only one test, right? So look at this item here. All we need to do is, because we know that they are mutually exclusive, we know that 12 over 42 plus 5 over 42 will give me 17 over 42, and I can divide this to give me 0.405. Okay, so the word or tell me to add. But then inside the word or, you have to ask yourself, do I just add them and call it a day if they are mutually exclusive? Or do I add them and subtract what they have in common if they are not mutually exclusive? Okay. And let's take a look at two more examples, and then I will ask you guys if you have a question. If you read this thing here, same thing go, I select one student at random, find the property of that student is a sophomore and a D student. Reminder that this one here, we select one student, and the word and clearly is not the word or. The word and here is basically, do I have any student that fit this description is a sophomore and also got a C on my previous test? Which is, do you agree that there are 3 individuals fit this description? There are 3 individuals is a sophomore who also a D student. And how do I find this probability? There's no adding or subtraction. This is just a simple event. It's just the word and, but it's still just a simple event. I'm looking for one particular item that fit this description. So I have 3 individual students that fit the sophomore and also a D category. Okay, and again, if I divide them, I get 0.071. Again, when you divide, you just type the numerator divided by the denominator. Okay, like I said, if you got like 11 point or 10.3, you did something wrong. Okay, so similarly, let's take a look at this item here. Let's take a look at, if I select one student, find the property of this student is a senior or a D student. And if you look at this item, this is my senior category. This is how many senior I have. And this is a D category. And if you can see, this is different from a sophomore and a junior, or sophomore or junior. And it's different from an A or an F, because as you can see, we have some overlapping. We have the 2 highlighted region overlap each other, meaning it's possible that these two criteria can come out at the same time. It's possible that they are a student who is a senior and also got a D. So if that is the case, then they are not mutually exclusive. And if they are not mutually exclusive, we need to take the property of a senior, which is how many senior do I have? I have 11 over 42, plus the D student, which is I have 7 over 42, minus what they have in common. What do they share? I have 2 over 42. And if I add them together, I have 16 over 42. And 16 over 42, I divide them to get me 0.381. Okay. And again, the reason I put them all together and instead of 11 over 42 plus 7 over 42 minus 2 over 42, because in order to add or subtract, your denominator have to be the same. And your total is the same total for all of them, which is, that's why it's 42. Okay. And the other thing is, you know, someone might say, wait, why don't we just add them like we did in A? And why do we need to subtract the 2? Well, one thing is, if you remember, or if you ask yourself, if I ask you how many senior we have, you say 11. And when you say 11, you count this 2 one time because the 2 is within the 11. And when you count how many D students we have, you say that there are 7. But again, also we count this 2 again one more time. We only have 2 students, but we double count the 2 students. And because we double count the 2 students, that's why we have to subtract one of them away. We have to subtract one of them away so that we don't double count this 2 individual. Okay, and that's the difference, or that's your general addition rule. You have to subtract the intersection. You have to subtract what they have in common. So in this case, wherever they intersect, wherever they overlap, that is the number you have to subtract out. If they don't overlap, there's nothing to subtract out. Well, you can subtract 0, right? If you remember my A and my F student, they do not overlap. And if they don't overlap, you subtract 0, which is 17. Subtract 0 is just 17, right? But anyway, question with this 3 item here. Question with A, B, or C. And a question on how I got the number and how I got the answer. All right. Let's take a look at D. So what is the property of a junior or an F student? Same thing go. You say, oh, this is a compound event. This is the word or is either a junior or an F student. And since we have a raw data, hopefully it's clear to see that this is my junior and this is my F student. And because the 2 highlighted region, they overlap, we know that we need to subtract something out. And what do we subtract out? Well, we know that 12 over 42, that's your junior, plus 5 over 42, that is your F student. And we need to subtract the 2 over 42, which is the overlapping of the 2 highlighted region. And if I add them and subtract 17 minus 2, I have 15, and 15 divided by 42, I have 0.357, meaning 35.7% that a student is either a junior or an F student. And you select a person and that person might be both, that's okay, because we only either a junior or an F student, okay? And that's your challenge, ladies and gentlemen. When you do your homework, when you work on this material, your raw information might not present it to you. You have to ask yourself, you know, when you read a question and you see the keyword or, when you see the keyword or, you ask yourself, well, do I have anything in common? Do they give me something that they say this and also that? If you say yes, then you have to subtract that common out. If you say no, then you just add the 2 of them and you are done, okay? So question with this particular example here. So the last example I have in this slide is, what is the probability if I ask you find the probability of not an event? Find the probability of not a junior. Well, if we have a raw data, we can see that we can do this item here like this, which is, do you agree that the freshmen, the 9 freshmen are not junior? The 10 sophomore are not junior, and the 11 senior is not junior, which is, we can see that this 30 student, 30 individual, right? 30 individual, why 30? Because 9 plus 10 plus 11, this 30 individual are not the junior category. They are a freshman, they are a sophomore, they are a senior. They are not a junior. So we can do this in terms that we just take whatever not fit the description or fit the description. The description we're looking for is not a junior, which is in this case not a junior. I have 30 over 42. I divide them to give me 0.713. So to find the probability of not something, if you have a raw data, you just find out that item and just put over the total. And like always, to find any probability, from here on out, whenever you find a probability of something, you always need the total. Without a total, you cannot find the probability. Okay, so that brings us to this definition: the complement of the event, the probability of the complement. Okay, the complement is basically the what left over, I should say, or what not that item. So in this book, the complement of event A, the complement of event A for this book, they say A sub C or superscript C. Okay, so if you Google or some other book, they probably have A prime, which is the complement, or A ball, A hat, which is A caret or A hat. Is the same, it's just different notation. For this author, he used the C to stand for complement. In short, the probability of a complement, meaning not something, is the same as 1, which is the total probability minus the probability of that event. So if you look at this thing here, if you go back to this item, and they say the probability of not a junior, and if you look at this thing here, we can use the complement of the event and say the probability of the junior, how many junior we have? Do you agree that the junior we have 12, which is if we were to do this in terms of our formula, we know that there are 12 out of 42. Those are my junior, right? Which is 1 minus 12 out of 42. So what is 1? 1 is 42 out of 42, because 42 out of 42, that is one whole number, minus 12, which is my junior, out of 42. Do you agree that 42 minus 12, 42 minus 12, that will give me 30 out of 42? And that is our answer from previous problem. Our previous problem show us that, right, instead of using this formula, we can just add the item that is not a junior, which is we have 30 out of 42. So the formula is there if you don't have the raw data. If you don't have a raw data, all you do is you take 1. Why 1? Because that's the maximum percentage you can get. The maximum probability is 1 minus the probability we're looking for. Okay, so again, probability, the complement is that 1 minus the probability of the event. So either way, you can either add the item that does not fit the description, or you can just take 1 minus the description. You know, and in the sense, it's very easy. In the sense that if I say that the probability of rain today is 42%, right? 0.42. That will be the chances of rain. What's the probability of not going to rain? What is the chances that it's not going to rain? Well, if 0.42 is the chance of rain, I can take 1 minus 0.42, which is give me 0.58, meaning 58% that is not gonna rain today, right? So the leftover from the 100, the complement of that, right? So 1, which is 100% minus the percent. We use 1 if it's a decimal, 1 minus the decimal, okay? So question with the complement or question with the mutually exclusive event or the general rule of addition. Any questions so far? So if you don't have question, this is the last item, a little bit confusing, so bear with me here. This is the last item we have for today, which is after I mentioned about probability of a complement, this item, example 3, we are not finding the probability, okay? So don't think until this item here is a small introduction when we get to chapter 5. We will use a lot of this in chapter 5, but for now, we want you to find this complement, the complement of this event, or I should say the complement of the qualifier. If you came from 120, the word exactly, the word at least, the word at most, those are the qualified statement, fewer than, right? So we want to find, if you came from 120, basically the negation of a qualified statement. So if we were to give you this statement here, the statement is exactly 24 battery that is defective. So if it's exactly, what will be the complement? What is going to be the negation of exactly? So don't worry about this 60 cell phone battery, right? This is what they tell you is I have, in this room, I have 60 cell phone battery. And now what's the probability if I go in and take exactly 24 battery and those 24 battery is defective, right? I'm sorry, not probability. What is the complement of me going here and select this exactly 24 of them? So think in terms of this way, which is again the battery. The battery is the discrete data, meaning you can either take 1 battery, 2 battery, 3 battery. You cannot take 4 and 4.5, 4 and 3/4, right? You have to take the whole battery, that's the discrete data. So if you look at this thing here, assume that this green line, green line is exactly 24, right? So what is the complement of exact 24? Well, 24 is this item. Do you agree that if I select 20, that is not exactly 24? If I select 41, that is not exactly 24. So the complement or the negation of exactly 24 is pretty much any other number that is not 24, right? Exactly 24, that's very restricted. I can only get 24 and nothing else. So what is the complement? Well, the complement will be anything other than 24. I can pick any other number, 50, that is not exactly 24, right? I can pick 10 defective battery that is not exactly 24. So the complement of the exact number will be not equal to that number. As long as it's not equal to that number, it's the complement of that number, because exactly you can only have one number. Everything else is the complement of that exactly one number, okay? Similarly, they ask you to find the complement of this event. What is the event? The event is at least 24. So the event is at least 24. So now this is what I tell my student is, whenever you read this event, ask yourself this question. Do I include the endpoint? Do I include the endpoint, which is 24? Do I include that 24? What is the word at least mean? Well, at least meaning 24 and up. Do you agree that at least meaning 24 all the way up to the maximum 60 number, 60 battery I have? Meaning I include the 24. And if I include the 24 in my event, this is my event. This is what I'm looking for. I'm looking for at least 24, meaning 24, 25, 26, 27, all the way up to 60. And if I include the 24 in my event, the complement will be fewer than 24, meaning less than 24, right? Because fewer than 24, 24, like I mentioned earlier, 24 is not fewer than 24, right? 24 is equal to 24, but it's not fewer than 24, okay? And to think of this thing here, a lot of students, I don't know why, but the word at least confuse a lot of students in the way. Think in terms of at least if you go to a casino, they say have to be at least 21 to enter, right? Meaning you can be 21 or 22 or 23, meaning you include the 21 years old, right? And again, who cannot enter? Well, 20, 19, 18, anything from 20 or below, right? Or we can say fewer than 21 because, again, younger than 21, right? 21 is not younger than 21, okay? So in the sense that the complement of at least will be fewer than that number, fewer than that endpoint, okay? So fewer than 24 is the complement of at least 24. And let's take a look at one more. Well, we have two more, and then I ask you a question, or after this one, I ask you if you have a question. More than 24. This is my event. My event is more than 24. Do you agree that more than 24 meaning it does not include 24? What number is more than 24? Well, 25, right? That's why I did not put my arrow at 24. It's 25, 26, 27, 28, 29, 30, and so on. Those are the more than 24 item, right? So my 24 is the green line, and more than 24 meaning is this item up here. So what is the complement of more than 24? Well, you have to ask yourself, well, if we don't include the endpoint in my event is more than 24, and I don't include the endpoint, then the complement have to include the endpoint. The complement have to be 24 or less, or in this case, 24 or fewer, because 24 or fewer meaning it can be 24 or 22 or 23 or 21 and fewer, right? So again, the most important thing is, first of all, do not confuse this problem with find the probability. And that's why a lot of you guys see, well, what do we do with the 60? We don't do anything with the 60. Those are your total item, right? Unless they tell you find the probability, then we have to do something with it, okay? For now, they're not asking you to find the probability. They just ask you, if I give you this item, can you find me the complement of it? And whatever this item is, the first and most important thing is you need to ask yourself is, do we include the endpoint? If the item include the endpoint, the complement do not include the endpoint. If the item does not include the endpoint, then my complement have to include endpoint. I have to include every single, just imagine that I have the 60 item. I need to include everything in it, okay? So that's why for C, the answer will be 24 or fewer, because 24 is not in the original black ink statement. That's why it has to be in the red ink statement, 24 or fewer. Question with C, or any question so far? Everybody got the small concept of this complement event. Well, the last item I have is fewer than 24. So what does it mean, fewer than 24? Do I include the 24? Well, I know fewer than 24 meaning, again, is had to be less than 24, right? Last time, this one here is 24 or fewer. That's why I included 24. This one, fewer than 24, I do not include the 24. It has to be 23, 22, 21, 20, so on, all the way down here, which is I do not include the 24. Do you see that if I don't include the 24 in my event, my original event, I do not include the 24. Therefore, my complement, I have to include the 24. You can say 24 or more, that's fine. They accept that. Or you can say at least 24, because at least 24 meaning 24 or more. Okay, so that's the idea here is if I give you one side of the number line, just think in terms of the number line. If I give you one side of the number line, can you give me the rest that I do not cover? Okay. If I give you one side, can you give me the leftover? So whatever this red arrow, that is your fewer than 24. The leftover will be 24 or more. Okay. Question with this complement of this event, and again, one thing is a lot of students get a little bit confused, and I mentioned earlier is they thinking in terms of, because I just introduced over here, I just introduced the probability of the complement, but this thing here, this problem, they did not ask you to find the probability of a complement. They just asked you to find a complement. Okay, so again, the complement of the event. So whatever they give you, they just want you to find out the leftover, to make it short, easy, right? If I give you this item, give me the leftover that is not fit this description. Okay. So any question here? Any question in general? Any question at all? Well, if you don't have question, that is the answer.